So hello everyone, in this video we will be solving another LeetCode problem and the problem name is Maximal Rectangle. So given a row cross calls binary matrix filled with zeros and ones, find the largest rectangle containing only ones and return its area. So what the question is saying that you are given a binary matrix, that means all the elements of the matrix are either 0 or 1 and you need to find the largest rectangle which contains all the ones. So this problem is similar to the problem of largest rectangle in histogram. So we'll be using the concept of largest rectangle in the histogram concept. So this question is prerequisite. So if you haven't solved this particular problem, you need to first solve this particular problem, then only you will be able to understand the idea and the intuition behind this particular problem, maximal rectangle. So I highly recommend to solve this question first, because I'll be using the same concept of the largest rectangle in the histogram in this particular question. So if you haven't solved this question, first solve this question. This is the prerequisite. Although I will give you the glimpse of what this question is and how do we solve this question, but I'll not go into much details of what concept we are using and how it is been working, because then video will be very long. So I'll just give you the glimpse of this question, but I'll not go into much detail. So I highly recommend you to solve this largest rectangle in histogram question first, then solve this particular question. So the question, the problem statement is pretty much straightforward. So you are given a binary matrix, you just need to find the largest rectangle area which contains all the ones. So this is the first example. So we can consider this as the one of the rectangle. So its area is what? Height is 4 and width is 1. So 4 cross 1, that is 4. We can consider this rectangle as one rectangle. So its height is 1 and its width is 3. So its what you can say, its area is 3. Now this is in itself one rectangle, this is one rectangle, there are many rectangles, right? This is one rectangle, but the maximum area rectangle is this one, the one I have marked with green. So its height is 2 and its width is 3, so the area comes out to be 6. So the maximum area or the maximum area rectangle in this particular example will be 6. So we will be returning 6. So how will we solve this question? We will be using the concept of largest rectangle in the histogram. So what was that question? I'll just give you the idea that what was that particular question and how we can connect this question to that particular problem. So I have just drawn one histogram. So let's say this represents the heights. So in the largest rectangle in histogram, we were provided with the heights array. So you can consider this as the heights array. So you can consider this as height 1, this as height 2, this as height 3, so on and so forth. These are the heights given to us. Now in this we need to find the maximum rectangle area. So I am just recapping the histogram question here right now, so that you at least understand what concept we are using in this question as well. But I highly still recommend to solve this question first. This is just the idea to make you understand what concept we are using. So in the histogram question, what we were doing, we need to find the largest rectangle among this histogram. So you can say that, okay, this can be one area, whatever its height is, its length, its width is 1. So we can just multiply height, whatever this height is, multiplied by its width is 1. Similarly, you can see that this is one particular rectangle that we can get. Let's say this rectangle. Yes. So whatever its height is, multiply by length. So how we were getting the answer in this question? So what we were doing, for a particular height, we were trying to expand towards its left and we were trying to expand towards its right. So we find the element which is lesser than this particular height, because then only we will not be able to expand towards either to its left or to its right. So in this case, whatever this height is, if we try to expand towards its left, this is the height which is lesser than this. So we cannot expand this height towards the left. So okay, no worries, we will try to expand towards its right. So this is the height currently that we have. So can we expand this height towards the right? No, because this height is lesser than this particular height. So we cannot expand this towards the right also. So for this height, our area will be nothing but whatever this height will be, height of I, multiplied by whatever the width is. Now what is the width? The smallest element towards its left and smaller element towards its right, its index. So let us mark this index. This index is 0, 1, 2, 3, 4, 5. So the smallest element towards its smaller element towards its right is at index 3. So 3 minus towards its left is 1. Okay, then minus 1 again. So this is the formula for calculating the width. So this is what we were doing in the histogram question. So whatever this height may be, height of I, we were just multiplying by 3 minus 2, that is 1. And you can see this height can only be expanded in one width, that is this particular element at index 2 only. We cannot expand towards its right and we cannot expand towards its left. So its width should be 1 and we got the width 1. So this is how we were solving that histogram question. Let me give you one more example for this histogram so that you can understand in better way, where we can see that okay, we can expand in its left and we can expand in its right as well. So what we should take? Okay, we will just take this particular element. So we are at this height, so we can say okay, how we will expand this height. So we will see, can we expand this height towards its left and towards its right or not. So towards its left, this height is larger than this particular height. So yes, we can expand it in left. So how long can we expand? So again we come across this height. Now this height is also greater than this particular height. So we can say okay, we will expand till here. Now we come across this height. So can we expand here? No, we cannot expand here because this height, this particular height is greater than this height. So we cannot expand this height because this height is lesser than this. So we can only expand this height in the left side till here. Can we expand towards its right? Towards its right, do we have any height which is greater than this? So just check the next element. So next element is lesser. So if the next element is lesser, we can't expand towards its right. So towards its right, we cannot expand it anywhere. So what height, what width we will get, how much we can expand towards its left and right. So again the index, so its index is 0, 1, 2, 3, 4 and 5. So for this index 3, what was the smaller element, what was the first smaller element? It was present at index 0. So how will we get the area? So whatever this height will be, height of I multiplied by width. Width will be what? The the smaller element index towards its right minus left minus 1. So its its right side index is 4. So this was the fourth index, was the first element where we got a height which is lesser than this particular height which we are currently present at. So this is at index 4. What was the height which we got the first time when we were expanding towards its left? What was the lesser height than this? So it was present at index 0. So you can see index 0 height is the first height which is lesser than this current height. So 4 minus 0 minus 1 again. So what is the area? Area is simply whatever this height will be multiplied by 3. So you can actually see we can expand this particular height into with width 3. So this is one width, this is second width and this is third width. So we can say that okay, for this particular height our area will be this, and you can see actually our width is 3 only, 1, 2 and 3. So we got the width correctly, and height is obviously is what we are expanding. So this is how we solve the largest rectangle in the histogram question. Now we will be using this same concept in this question also. So how we can use this same concept, let me just show you. So this is the matrix that the first example has provided. So can't we consider this first row as one histogram? After that, can't we consider this second row as the histogram? Can't we consider this third row is the histogram? Can't we consider this fourth row as the histogram? Yes. If you consider this first row as the histogram, we will have this one height, then this 0 height, then this 1 height. If we are considering this second row as the histogram, so we will get the height as 2, then we will get the height as 0, then we will again get the height as 2, then we will again get the height as 1 and again get the height as 1. So we can try the base of the histogram for each and every row. So let me just show you what I am saying. So when we consider the histogram from the first row, it will look something like this. So sorry for that. Yes. So if we consider the first row, if we try to make histogram from the first row, it would look something like this. So 1 will be the zeroth element height, then this will be the height 0, then again 1, then 0 and 0. So how it will look? It will look something like this. So this is how the histogram will look if we try to create histogram from the first row as the base. Now how will the histogram look if we try to create histogram from the second row as the base? So if we consider second row as the base, so the first or the zeroth element height will be what? 2, because this is 2, then this is 0, then this is again 2, then this is 1, and then this is 1. So how will the histogram look? How will the heights array look for this particular histogram? Because in the histogram question we were given the height array, so we are just calculating the height array. So its height array would look something like this: 2, 0, 2, 1, 1. And how will the histogram look like? The histogram will look something like this. This is 2 height, this is 0 height, this is 2 height, this is 1 height, this is 1 height. Now what if we try to create histogram from the row 3 as the base? So if we consider row 3 as the base, which is this particular one, so first zeroth row, the zeroth element height will be 3. Okay, we are getting 3. The first element height will be 1, so okay, we are getting 1. The second element height will be what? The second element height will be again 3. This is the 3 what I am marking here, so again we got the 3. The third element height will be 2. This is 2, so we are marking 2. The last element will be again 2, so we are getting 2. So this is the height array we get if we are considering to build the histogram from the third row. So this is how the histogram will look like. This is the height 3, this is height 1, this is height 3, this is height 2, and this is again height 2. Now what if we try to create the histogram from the last row as the base? So if we are considering last row as the base, so just let me just erase this entire thing and redraw this. So I have redrawn the entire matrix. So what if we try to create a histogram from the last row as the base? So our histogram will look something like this. So this will be the histogram. The first height will be 4, so we are writing here 4. The next height will be 0, so we need to consider from the base. We don't need to consider this height, because if the base is 0, then there is no point in considering this height. So the base is 0, so we will write 0. Again this is 0 height, so we will write 0 height. Now again we have the height as 3, so we will mark the height as 3. Now again we have the height as 0, so we will mark this height as 0. So this is how we are building the heights array. But how will we create it? Okay, for the first row we can say that this will be the simply the row as it is. But what about the subsequent rows? So we can simply take the prefix sums. With the help of prefix sum we can build these arrays as well. Simply whatever the last height was, simply add +1 to it. If and only if there is 1 present. If there is not 1 present, simply write 0. We don't need to consider these heights as well, because if the base is 0, we won't consider the heights above. There is no point. So if it is 1, just simply add 1 to whatever the previous height was. Otherwise, if it is 0, simply write 0. So with the help of prefix sums, we'll be calculating these heights as well. And I have just drawn the histogram visualization also. So for this last one, you can see this is height 4, this is 0, this is 0, this is 3, and this is again 0. Now we have already seen the question of let's say largest rectangle in the histogram. So we will use the same code which was there in the largest rectangle in the histogram. So we can create a function for that particular code. So what we can just pass these histograms into the function to get the largest area. So let's say we pass this histogram into the largest rectangle histogram function to get the maximum area within this histogram. So we will get the maximum area to be 1 in this case, because there is only one height, that is 1, and we can expand it to 1 width only. So 1 cross 1. We will pass the second histogram into the largest rectangle in histogram function. So we will pass this into this function. So this will return us the maximum area as 3. So how 3? Because we can expand this particular one towards its right and towards its left. So this width will be 3 and the height is 1. So 3 cross 1 will be the like what you can say area. So 3 is the maximum area, which is nothing but 3 cross 1. Now we will pass this next histogram into our function to get the maximum area. Now when we pass this particular histogram, we will get the maximum area is 6. How 6? We can pass this particular, we can just expand this towards its right, we can expand this towards its left. So width will be 3 and height will be 2. So 3 cross 2 is 6, so that's why we are getting 6 as the largest area for this histogram. Then we are passing this histogram into our function. So for this we will get the maximum area as 4, because this is the height 4, we can expand it only one with width 1. So we will get the maximum area as 4, which is nothing but 4, which is height, cross width, that is 1. So 4 cross 1, that is 4. So for this histogram we will get the area as, or the maximum area as 4. After getting all the maximum areas, within these maximum areas we will try to find what is the maximum area. So for this histogram we get the max area is 1, for this we got 3, for this we got 6, and for the last one we got 4. Now among these maximum areas we will choose whatever is the maximum. So we have the 4, okay, let's see if we can get some other maximum area or not. So for now 4 will be the maximum. Then we come to 6, okay, the maximum area that we have till now is 4, and this 6 is greater than 4, so we will update our max area with 6 and we will go forward. Let's say we to find whether we can get a maximum area which is greater than 6 or not. Then we got 3. Now this 3 is lesser than 6, so we will not update our maximum area, we will just move forward. Now we got 1. This 1 is lesser than the maximum area, that is 6, so we will again not update our maximum area. We have checked with all the maximum areas and the final maximum area that we have is 6, so we returned 6. And if that is what we were getting when we were seeing this example. So this was the maximum area which we were getting, that was 6. This is nothing but 3 cross 2. So our idea of using the concept of largest rectangle in the histogram is correct, because this is how we are just computing the maximum areas by passing each and every histogram into the function and just getting the maximum areas. And among those maximum areas we are finding the global maximum, and we got the correct answer. So this is how we'll be solving this problem. Now I just show you the code of this function which we'll be using to find the largest area in the histogram or the largest rectangle in the histogram. So this is how we are doing. I'll not go into much detail, I'll just explain the main function. This uses the concept of stack, next greater element or next smaller element, you can say. In this case it is next smaller element, so we are using the concept of next smaller element in this particular function. So you can obviously solve this particular question. I am just giving you the glimpse of what we are doing. For each and every height we are just saying how much we can expand towards its left and we can expand towards its right. So we are doing with the help of find next and find prev. Find prev will give how much expand we can do towards its left, and find next will give you the how much expand we can do towards its right. With the help of these we can get the width. Width will be what? Since we are using next and prev variable, not right and left, we are I am just explaining with the help of that. So how we were able to calculate the width? We were calculating the width as right minus left minus 1. So in this case right is what? Right is next, left is what? Prev, and minus 1. So this is how we'll be calculating the width. So our width will be nothing but next of I minus previous of I minus 1. Same thing, next minus prev minus 1. And how we are getting the area? Simply length into whatever the width is, length into breadth. And length is what? The current height which we are trying to expand. And we'll just return the maximum area. And how we are calculating this next and prev? Again, you can just solve that particular question. We are using stacks, the concept of next smaller element, and with the help of stacks we are getting the what you can say, the right part and the left part. So this is what the function looks like. So for each and every histogram we are doing this same calculation again. So let us see the code now. So I hope you understand how we are going to solve this particular problem. So let us see the code now. The code is pretty much simple as well. We are just using the histogram concept, so that's why the question becomes actually easy. So this is the code. So first I am declaring two variables n and m, which is nothing but the size of the matrix n cross m. Then I am creating a new matrix which is this particular one, matrix x, which is nothing but the same matrix, just I am converting it into the integer matrix. So you can see that here we have given the character matrix, so I am just converting it to integer matrix. So if we have the character 1, convert it into what you can say, integer 1. If you have character 0, just use integer 0. So first of all, I am just converting the character matrix into integer matrix. Now we need to calculate the largest area. So this is the histogram function that we are calling. So let me just show you. Yes, this is the main function of the largest area, largest rectangle in the histogram. This is the same code which I have just told you, next of I minus previous of I. The same code I am using it here. The same concept is being used. Find prev using stacks, then find next using stacks. Same concept, next smaller element and all that. So this is the same code as of the largest rectangle in the histogram. So we are just using that particular as our you can say, to get the largest rectangle for this particular histogram. Now what we are doing, we are passing each and every row as the base of the histogram. So if we are at the first row, we can create histogram like this. If we are at the let's say second row, so we can create what you can say, histogram like this. So we need to calculate first the sum. When we are coming from one row to other row, we our height is expanding. So with the help of prefix sum technique, we are just calculating the new height when we are coming to the new row. So we are just calculating the new height. If the matrix of I comma j is not 0, that means obviously it is 1. So whatever the I comma j is, just add the value of the previous one. So if the previous one was 2 and the current is 1, so you will get the new height as 3. Now otherwise, if it is equal to 0, in this case it was 1, but what if this current value is 0? So simply just write 0, because if we have 2 in the upper part and if you have 0 in the upper part, you can't say okay 2 plus 0 we will get 2. No, if the base is 0, we won't consider the above height. So if the matrix of I comma j is 0, simply use the prefix sum as 0. Now after calculating the prefix sums for each and every like you can say the column, when we are expanding the row, just calculate the maximum area. So with the help of largest rectangle in the histogram, we are calculating we are calculating the maximum area inside the current histogram. So this will give the maximum area in one histogram, and this area will compare the global maximum that we have considered in the end. So we had few maximums, like this was one of the maximum area for histogram, let's say 1. This was one of the maximum area for histogram 2. Now among all those maximums, we need to find the global maximum. So this is what this area is calculating. So whatever is the global maximum till now, compare it with the current maximum, and if the current maximum is greater than the global maximum, just update your global maximum with this current maximum. So this is how we'll be solving this problem, and in the end we are just returning the area. So I hope you understand this problem. So thank you for watching.